and he's here to do some maths. And he hasn't advertised it at all because he's terrible, but he's awake, and that's the main thing. We're here to do some learning today. We're going to learn about parallelograms, rectangles and triangles. I'm going to check that I remember to click to go live, because if I didn't, none of you can see me. You can. Some people are here. That makes me happy. We are going to look at these three different things and hopefully learn something, have some fun. And I'm going to, after I've done the lessons today, so I've got one now, and we're going to have one at 1 o'clock for the number side. Then after that, I'm going to get a timetable out for this week and next week. I'm going to try and get ahead of the game, get myself organised, and share all of that on Facebook and on here. A few changes that I've got coming up, which I'm going to try and do. So let's go straight into it. Okay, with that, so we are going to look today at three different shapes, and we're going to look about a few different things that go on with it. So, years and years and years ago, back in olden times, there were no such thing as shapes. There was just black and nothing, and no shapes existed at all, and everything was higgledy-piggledy and all tangled up. And one day, obviously, a mathematician, one of the earliest mathematicians, cave-time mathematician, was like, walked in, and he had this big tangle of lines. He's like, big tangle. But someone got his tangle, and he completely ruined it. And he's like, oh no, look, I've made it so it's this shape now. I've made your tangle of lines so it's this shape. And he said, oh, you've wrecked my tangle. And that's obviously how the rectangle was invented. Definitely, that's a true story. Now, with a rectangle, which you've been learning about since you were like year 1 or 2, we have a few facts that we just want to make sure we cover, because without covering these, we can't expect to move on to the triangles and parallelograms part of today's lesson. So with our rectangle, there are 2 bits of information that we're going to care about. And if anyone has been watching the BBC Bite Size, I think there's a thing this week with a Man United player. I forget his name. My brain's gone completely blank. It will come back to me at some point. But he did a thing about the area of a rectangular pitch this week. I want to say Linden. I can't remember. I know it's JL. I'm sure it is. Anyway, he was talking about the length and the height or width. If you do it this way around, it's height, but you can have width as well. And we've got 2 facts. So we've got the fact that if you want to know the area, which is the distance, the amount inside, it's going to be length times height, or base times height. You can sometimes call this the base. Length or base, and height or width. You'll sometimes see it as length times width. Sometimes you'll see it as height times base, or base times height. It doesn't matter. You're just because what you're doing is you're finding the amount of space inside. But without an example, this is not particularly helpful. So let's have another example over here. Now, in a rectangle, opposite sides are the same length. So if I write this down and this down, length times width tells us that the area must be 28. We need some units. Let's say that's centimetres and that's centimetres. We're going to have centimetres squared. Area will always be squared units. The other thing we're sometimes interested in is the distance around the outside. And to do so, to do the perimeter, it's named after Perimeter, who was a very early runner who used to run around, once these rectangles were invented, he used to run around the outside of them. But it's true of any shape. Perimeter will run around the outside and tell you how far he's run. Or she. I can't remember whether it was a boy or girl, because Perry Shakes Drayton is a British athlete, I believe. So Perry is a boy's and girl's name. Now, if she goes there, she's going to go 4 and 7, and then another 4 and another 7. So the perimeter here is 22 centimetres. Now, this might not be very new, because we're year 5 up to year 9, so it might not be very new for people, but I'm just getting us to the stage where we're happy with this, because everything I'm going to talk to you about in terms of the parallelogram comes from this basic principle. It's understanding perimeter, and it's understanding what the area of a rectangle is. Because if I can go through this with you and you understand those 2 things, The area being 4 times 7, and the perimeter being 4, add 7, add 4, add 7. That's all I have to do for now. Because if I now draw a parallelogram, parallelograms are made by pushing over a rectangle. They have to have a pair of parallel sides and then another pair of parallel sides. And we show it by having those two lines like that and those two lines like that. You'll notice I've used 2 arrows on the side ones and only 1 on the top. That's because if I only use 1 arrow, it looks like this. The 2 arrow one is parallel to the top one, but it's not. You use, if I was to have a different one, there are shapes, for example, hexagons, where in a hexagon, those 2 are parallel, these ones are parallel, and these ones are parallel. So we have to use up to 3 lines because they're different from theirs, and which are different from those, which are different from those. Okay, so that's just showing you how those arrows work. I also want some measurements. I've got 8 meters and I've got 5 meters. Now, old perimeter, quite happy, she'll get stood on the outside and go, ready, off she goes. And she runs around the outside because the perimeter is just round the outside of the shape, and Perry's happy because just like in a rectangle, it's going to be the opposite sides are the same as each other. So the 8 is equal to the 8 and the 5 is equal to the 5. So for the perimeter is just going to be 5 plus 8 plus 5 plus 8. Now, that to me is quite interesting in terms of we can always find the perimeter of any shape just by knowing the distances around the outside. However, so let me just finish that off. We've got 1626 meters. Not the furthest perimeter we've ever run, but perimeter can always be found for any shape. But when it comes to finding the area in the middle, we have a problem. Because without knowing a fact, people are tempted to just go, oh, I'll do 8 times 5 then. And that doesn't work. But if I show you this, if I was to cut this bit of the shape out, I'm going to use a pair of scissors to snip, 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 snip. But in order to do so, I'm going to get rid of perimeter's root because she might get confusing. So we're going to let perimeter go and have a rest for a bit. I've rubbed out way more than I meant to. I have to put that back in. So we'll get rid of perimeter's root. And this bit here, I'm not going to change its size at all. I'm going to put these 2 lines back in. All I'm going to do is move it. Cut it off and move it to this end. But in order to do so, I'm going to draw the new shape directly below. All I have done is cut off that yellow bit and moved it to the other end. You can see the amount of space has to be the same. The area must be the same simply because I've not changed it at all. I've just snipped it off and moved it to the other end. The area of this rectangle must be the same, but we've already said in the previous bit that the area of a rectangle is the base times the height, and we don't know the height here. We only know that that's 8 meters, and we got this weird slopey bit. That distance is 5, but we want to know that distance. This is the reason that we need to know when we're doing the area of a parallelogram, not the slope which perimeter needs, because perimeter's going around the outside, but we need to know this bit here, which is always going to be less than the slope. Not necessarily always 4 and 5, but it's always going to be less. Once we've got that, that tells us that this is 4. We're not interested in the perimeter of the rectangle because that has now changed. The perimeter has changed because we've moved the shape around, but the area is the same. So the area, when we already know this, is 4 times 8 is 32 meters squared. Therefore, this must be area of 32 meters squared because all I did was cut a bit off the end and moved it to here. I didn't change the shape at all. That can be summarised as a general rule if I use a phrase called the perpendicular height. Perpendicular is just a posh word which means straight up height. So, the perpendicular height is the straight up right angle height. Perpendicular means at right angles, so the right angle height, or the right angle measurement. So once we know that this one is 12 centimetres, for example, even if this one's 7 centimetres, and that one's 5 centimetres, what we're going to do is we're going to ignore, perimeter ignores the 5. So let's do perimeter first. She's going on a run, she doesn't care about the middle, so she ignores it. 7 plus 12 plus 7 plus 12. That's what perimeter would do. So perimeter would be 7, 19, 26, 28, 38 centimetres. However, if we want to do area, we're going to ignore the 7s. Because we remember, we can always cut this triangle off. Could cut off, I'm not going to move it, but I'm going to say that I could cut that off, put it on the other end to make it a rectangle. Which means the area must be 5 times 12, which is 60 centimetres squared, and the 7 gets ignored for area. So for the perimeter, the inside measurements gets ignored, and from the edge, the other one. It's an excellent question, Sophie. The 4, I've measured it. It wouldn't be that you're expected to guess it. I have measured this 4, and I've made it up basically, but it would come in the question. So you could measure it if you had a shape that was measurable, but if it's just in the question, they might give you... I'll give you another question to show you, because it's a brilliant question what you just asked. So what I'm going to do, just to leave that on the screen so anyone who wants to pause it can, I'm going to do a new page. So what Sophie's saying is, where do we get the numbers? Well, your question might... The thing is, I'm trying to teach maths, so it's not about, oh, you're given a question. If we come across a parallelogram and want to know stuff about it, it's not about given a question. This is what we've got. You've got these measurements all given to you. 6 centimetres, 7 centimetres, 10 centimetres. You then have to decide, is the area A, 60 centimetres squared, B, 70 centimetres squared, C, 42 centimetres squared, or D, is it 420 centimetres squared? So that's what you've got to decide. We're talking about the area. While you're having a think about it and putting your answers in your thing, in the live stream, I'm going to just get Perimeter along, because she's just like itching on her blocks going, I want to run around the outside. 7, 10, she ignores the numbers in the middle because she only cares about the outside. Perimeter is going 7 and 10 and 7 and 10 is 17. 17 is 34 centimetres. You've run so far, Perry, and you're going to be exhausted at the end of today. So Sophie's got an answer. Anyone else got an answer? And Nitesh's got an answer. Eddie's got an answer. So it looks like people are agreeing on their answers. So hopefully you've said at home, if you're doing this not live, you've gone for 60, because for the area we care about the straight up height times that, and we ignore the outside slope height. It's just the base times the height, but it's the perpendicular height, because this is the word we've talked about today, perpendicular. And this is the bit I love. The reason I focus on parallelograms is because I can sit and say to year 5s and 6s and 7s till I'm blue in the face how to do triangles. But if they fully understand parallelograms, like we've just looked at there, I don't need to explain triangles, because they look at it and go, oh, it makes sense. Because if I've got any triangle in the world, I'm trying to make a weird one, and I get that triangle and I do a copy of it, and I take that copy and place it upside down next to it, I will always, without fail, make a parallelogram. doesn't matter what the triangle is, as long as it's a copy of itself, so that, as long as they're identical, if I put one on top of the other, I will make a parallelogram. But we've just discovered that the height of that triangle and the base of that triangle is going to be the base times the height, will be the parallelogram. So the area of this whole parallelogram is base times height. However, we have two of them. And we only want to know the area. Let me show you in the correct one because I want to make the diagram look the same. Oh, don't want to rub that out. So this triangle, if we just want to know what the area of the red triangle is, we must go, oh, I'm going to do base times height, but that gives me all of this shape here, and we don't want all of this shape here, so we're going to have to do half of it. This is the reason teachers up and down the country are saying to you, you've got to remember to halve it. You're halving it not out of some random formula. It's not that someone's coming and going, I think we're going to halve this one. We haven't got Jeff Half who's like, I like to halve things, so can I have some halving, please? That's not what's happened. What's actually happening is we've got two triangles which are the same. We put them together, we make a parallelogram. That's base times height. Therefore, the area of the triangle must be base times height and halve it. But remember, the height is the perpendicular height. I keep going on about this. It's at right angles to the base. I know that's not flat, and that's allowed. In fact, I could have used this as the base and used this as the height. It doesn't matter which number you use as the base and the height, as long as you've got right angles between them. But we didn't. We used this base and height, and the area is half times base times height. Now you'll see lots of different ways of writing this, and it's absolutely fine. If your teacher said, oh, it's base times height, then halve it, that's fine. If it's half of the base times the height, that's fine. If they put it in brackets, that's fine. Because you don't need brackets, because multiplying is something called associative. I'm not going to make you learn that word, but it just means the order doesn't matter. 4 times 3 times 2 is the same as 2 times 4 times 3. They're the same. It doesn't matter which order you do them. As soon as you add in some adding and taking away, that we lose that. But when we're doing it as multiplication like this, sometimes people do base times height at first. You don't actually need to. But what I've tried to do is teach you why. Sorry, Sharanya, I do remember that you're Sharanya. I always forget. Try to put Sharanya before you write the messages, like first few messages every day, so I remember, because it's difficult to remember everyone who's in the chat. Good morning, Charity. So, hopefully, we are understanding why it's base times height and halve it. Base times height for the parallelogram, base times height and halve it for the triangle. Now, I know what you're thinking, but what about Perry? Don't worry, she's here. Perry does not care about this height at all. Perry just wants to know what this distance is, what this distance is, and then runs along the base. Perimeter always just goes around the outside, does not care about middle bits, doesn't have any special halving or special rules. It's not about a formula, it's about understanding that perimeter is just around the outside. Now, the practical applications for this is that you might have you might have things like building frames. You need to know how much wood to use. Perimeter would tell you exactly the amount of wood to use, because the outside is like literally the distances of the bits of wood. Now, the interesting thing is, now I've gone through rectangles, parallelograms and triangles, and let's just do one triangle just to be clear. I'm going to give you lots of numbers in this triangle, deliberately. 8, 7, 11 and 6. Is the area going to be 42 centimetres squared? Is the area going to be a B? Is the area going to be 66 centimetres squared? C, is the area going to be 44 centimetres squared? or D? Is it 33 centimetres squared? The perimeter, while you're doing that, I'll get Perry. She's coming along and she's like, brilliant, I've got some things. I've done 8, and then I'm doing 7, and then I'm doing 11. So perimeter has got 8 and 7 and 11. She's happy. She's done another 26, whatever the measurements are. If it was meters, we put meters. If it was miles, we put miles. Okay. So, good morning, Sophie stroke Josh. How are we getting on with this? Any questions? I love that you're saying hello to Perry. She loves it. She's really happy because she's had her workout today. She didn't get up in time for Joe Wicks, so she's doing some laps of our shapes in the video today. So we've hopefully got an answer of D. We wanted the 6, the 11, and halve it. We want the base, the height, and then we halve our answer. So 6 times 11 is 66. Times half is 33. So, hopefully, Sophie McLaughlin, do you understand? It's not, you've gone for 66. That would be base times height, but what we learnt with triangles is that would make this shape. If you did 6 times 11, you'd make that shape. But we only want the triangle, which is going to be half of it. We only want this bit. So if you did 66, you've done a correct thing, 6 times 11, but you still need to halve it for it's a triangle. Hopefully that makes sense. Does that make sense, Sophie? She'll respond to me maybe in 9 or 10 seconds when the video catches up with her. So that's why it's D. 6 times 11 is 66. Divide by 2, or halve it. So these mean the same thing. Times a half or divide by 2. If you're not clear on that, they mean the same thing. 6 times 11 divided by 2 is the same as 6 times 11 times half. They have exactly the same meaning as each other. Half is the same. Timesing by half is the same as dividing by 2. In fact, what some people don't realise because they get scared, I have taught you enough today to do this question without any problems. X, 3x, 2x. What is the perimeter and what is the area? Now, this is where some people go, it's letters though, it's letters, Mr. Harris is scary. No, we just stay calm and we go, okay, first of all, let's bring Perry in. Yeah, I get to do more running. I'm going to do 2x and 3x. I'm going to do 2x, 3 more x's. So let's write those down. 2 x's and 3 x's and 2 more x's. And 3 more x's. We've run a total of 10x. We don't know what that is until someone tells us what x is, but that's okay. X just means an unknown number. Our final answer for perimeter at the moment is 10x, and we call that an expression. We're allowed to leave it as 10x because the question might say, write an expression for the perimeter. So we have 10x. It doesn't need to be a number. The area, well, the area is base times height. Remember, we do not need to halve it because this is not a triangle. We're not trying to confuse ourselves. If it was a triangle, we'd have to halve it, but it isn't. So we're just going to do area is 3x times x. The one bit of maths that we have to use, this is why I don't like times. Algebra doesn't use times because x times x, look how messy that looks. What instead we often write until you've combined it is just 3x brackets x until it's been combined. In Europe, so if you've got any people who are like Polish or Macedonian, Lithuanian, or anyone with a different background, Romanian, they don't use decimal points the way English people do. So we write 2.4, they write 2.4. This, in Europe, the point would be further up, be in the middle. This means 2 times 4. So if you've got any Polish friends or Croatian or European friends who get confused by the way you write your decimals, that's why, because they have a different way of writing it. And that makes it nice and easy because you could just write 3x dot x and it would mean the times by each other. So you might see in a textbook sometimes, for especially A levels, something like that. And that's fine, it just means times. But what we have to do is remember that when you times x by x, you get 3x squared. If you times a letter by itself, you get x squared. So Perry's gone round and done 10x, where And the area on the inside, remember, area is the space on the inside. And so the space on the inside is 3x squared. Hopefully this makes sense, because when you do the perimeter 10x, very good. The area is 3x squared, Sophie, because when you times x by x, you have to get x squared, because you're timesing a number by itself, and that's what squared means. X squared means x times x. It's messy, I know. I'm going to change how that's written so you can see the letters easier. It means x times x. Another way of thinking about this is 3 times x times x is 3x squared. That's why the answer is 3x squared, because it's 3 times x times x. So that's where we get the 3x squared from. Oh, nice to see, Eddie. Your mum's at Ukraine. Have you spoken to her? Do they have in Ukraine? Do they have a similar approach where, so if you were to ask your mum, does that mean 3.4 as we would write it? I'm interested to find that out. You're absolutely right. What we do, Sophie, if you're doing a chat and you want to write the squared symbol, which is fantastic, what you do, you use this 3x little hat 2. It's I think you can find it on Shift 6 on my keyboard. Shift 6, that's how you can write it. Another way of writing it is 3x squared. Just write it in words. Good morning, Katie. Lovely to see you. I miss you loads and loads. Katie's someone from my Year 11 class who sadly I don't get to teach anymore because they finished. But she's a very, very hard worker who I very much enjoyed teaching. And I miss loads from all the lockdown. So good to see you, Katie. So hopefully this has been useful to you. I hope you feel you've learned something today. I've hopefully imparted some knowledge on you on some all sorts of different things we've been doing. We did some rectangles, parallelograms and triangles. I've tried to make it some sense to you. I hope it has. If you've got any questions, use the comments below the video. There's also a link in the description to where you can go and get some practice on this. Mr. Barton website. I'm going to be back for some more lessons on Friday. I'm going to try and do an escape room for the transition pupils if I can get enough time to put it all together, which I'm going to try and do on Wednesday. There's also going to be a few changes and stuff, and keep your eyes peeled on the channel for the timetable for this week and next week, where I'm going to be letting you all know what you're doing a bit ahead of time, because I've been a bit... I'm going to blame entirely my daughter. It's all her fault, because all she does is cry all night and keep me up. No, I'm joking. Thank you very much for joining me. I've been Mr. Harris. You haven't. Speak to you soon.